Solving two-step inequalities, and we're going to look at in context. All right, here we have, it's kind of aligned weird, but here we're solving the inequality. We're going to graph on the number line and determine which given values are solutions. So I'm going to do this in blue. So we treat it just like a two-step equation. We want to isolate the x, so we move everything else by doing the inverse operation. And I'm keeping the inequality like it is. So now I'm going to divide by 2. So x is less than 3 halves. It's also less than 1 and 1 half. So I'm going to do 1 and 2. So this is 1 and 1 half, or 1.5. And this is 0, and this is -1, 3, and 4. All right, so I know x has to be less than this value. It's not less than or equal to. It cannot be 1.5. It could be 1.25. It could be 1 and 1/10. It could be anything below. So could it be 1? Yes. Could it be 0? Yes. Could it be any negative number going to the left? Yes. How do we check this? Well, it couldn't be 2. It couldn't be 3. So let's to make sure. So if I substitute 2 in for x, is 2 less than 1.5? No, it's not. It's greater than. If I substitute 3 in, is 3 less than 1.5? No, it's greater than as well. So that's how I know to shade to the left. Anything shaded could be a solution. So we have -9, -5, 0, 1, and 1/2 can all. With this situation, we have 1/2 x plus 10 is less than or equal to 5. So in order to truly understand this one, we have to solve for x just like we did before. All right, so give me 1 second to get everything situated. All right, so in order to do that, we have to take and solve this like a two-step equation. So we're going to have to subtract 10 on both sides. So we get 1/2 x is less than or equal to -5. And to undo multiplication, the 1/2 multiplied by x right there, I'm going to have to divide by 1/2. Well, we know dividing by 1/2 is the same as multiplying by the inverse, which is 2/1. So x is going to be less than or equal to -10. So I'm just going to put -10 in the middle, then -8, -6, and so forth, -12, -14. All right, I know x has to be less than or equal to -10. So it can be equal to because of that bar underneath. So I'm going to shade this in, close circle, because that can be a solution. Anything I shade can be a solution. Now, x has to be less than that because we know the inequality opens up to the greater numbers. So -10 is the maximum. So I know I would shade everything to the left in this situation. Now, let's check and see what works. Is -8 shaded on the number line? No. I can substitute in, is -8 less than or equal to -10? No, it's actually not, even though 8 and 10 positive would be a different story, but 8 does not work. Is 5 less than or equal to -10? 5's way to the right, so no. Is -10 less than or equal to -10? Yes, because it's equal. is 0. 0 is way to the right, so 0 is not an option. Is negative 15? Well, negative 15 is going to be right here, and so that means it can be a solution. Is 6 less than or equal to negative 10? No, 6 would be right to the right. And then negative 4. Negative 4 would be still to the right, but that doesn't work. So the only solutions in this set are negative 15 and negative 10. So now we're looking at writing and solving and graphing inequalities, so all combined. So Herschel has $1,000 in his bank account. So he wants to keep at least 700. So I'm going to put 700 on the right. He withdraws $30 each week to pay for gas. How many weeks can he withdraw and still have at least $700? So he started with 1,000 and then he's subtracting 30 times the number of weeks. And we want this to equal bigger than $700. Can it do equal to? Yes, because it says at least. So greater than or equal to. So then I solve this by doing two-step equations. So I get 30x is greater than or equal to negative 300. Negative 30x is equal to negative 300. Now, here's the tricky part. So you have to recognize that we're dividing by the opposite. So we're dividing both sides by negative 30. But when we do that, we also have to change the inequality sign to its opposite. So x is not now greater than or equal to, it's less than or equal to negative 300 divided by negative 30, and that gives you positive 10. To graph the solution on a crazy number line, we have 10. Let's say 15 is over here, and let's say 5 is over there. So it says x is less than or equal to 10. So it says it equals to, so I'm going to include that. And that means the number of weeks has to be less than 10. So 5 is less than 10, 7 is less than 10, 8 is less than 10, 9 is less than 10. So all of these down to 0 because we cannot have a negative week. So interpreting the solution. So what this means is Herschel will still have at least $700 in his account if he withdraws for 10 weeks or less.